All right, class, Algebra 2, Lesson 4.1, Organizing Data with Matrices. So what we're going to have is a whole chapter involving matrices and try to learn the aspects of them. You might say, I have no idea what a matrix is. It's okay. This first lesson is designed to help you to understand a little bit about matrices, and as each lesson goes by, we'll learn a little bit more. They're quite valuable. A matrix can be used in a lot of different ways. Probably the biggest thing today is in the use of computer programming. And there's a lot of use there, mostly called arrays. So take a look at number one right here. Number one, what is a matrix? A matrix is a rectangular array of numbers. So to the left is some spreadsheet data that is then made into a matrix on the right. So the matrix is there on the right, a rectangular array of numbers. All you see is numbers. So it may have come from a spreadsheet to the left, but the matrix itself is the rectangular array of numbers. All right, matrices. So when you talk about matrices, you talk in the same terms as a spreadsheet. You talk in terms of rows. So take your red there. And we have 3 rows in this matrix. So you got your top row, right? And then you've got your middle row, 38, 25, 15. And then, of course, your bottom row, 12, 15, 50. So each matrix is made up of its rows, and then I'm going to grab my green, and of course it's columns. It's rows and it's columns. And you see column 1 there, 25, 38, 12, which, by the way, represents the amount of Coke, right? The amount of Coke. You got your second row there, 35, 25, 15, represents the Sprite. And then you've got the 10, 15, 50, and that represents the Mountain Dew. All right, I don't care for dew, but maybe you do. So you got rows and you've got columns, and let me get the word column back up there. You got rows and columns. And I didn't mention this when we're doing the rows, but notice the rows represent how much Coke, Sprite, and Mountain Dew is in the closet in the first top row. Second row representing how much Coke, Sprite, and Dew is in the machine. And then the third row, how much Coke, Sprite, and Dew has to be ordered. And again, these are just fictitious numbers that I came up with to just give you a little idea of the concept. All right, so each number of the matrix, and you can see, you got a 25 here, you got a 25 there, you got a 15 there, et cetera, et cetera. There are 9 different numbers here in this matrix. Each number, and I'm just going to put this right over here, a little asterisk. Each number is an element or entry. Is an element or entry. So the 25 on the top left is an element or an entry. The 35, row 1, column 2 is an element, entry, et cetera, et cetera. So you got rows and columns, and each number of the matrix is called an element or an entry. Now, real important, matrices are described by their, take my red, rows and their columns. And do not get it backwards. Rows first, columns second. Rows first, columns second. So our example right here has 3 rows and it has 3 columns. So it is a 3 by 3 matrix. 3 rows, 3 columns. We would also call it a square matrix, right? 3 by 3 square, 2 by 2 is a square matrix, 7 by 7 a square matrix, etc., 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 etc. But you describe a matrix by its rows and columns. And again, you can't get it backwards. It's got to be rows, then columns. So take a look at the 4 example matrices we have across here. So matrix A is a what? And hopefully you're going to say how many rows, then how many columns, and this is a 3 by 2. You cannot say 2 by 3. It's the rows and then the columns. 3 rows, 2 columns. In case you miss it, row 1, row 2, row 3, column 1, column 2, right? 3 rows, 2 columns. Matrix B is a 2 by 3, right? 2 rows and 3 columns. So what would C be? What would C be? And hopefully you're thinking a 1 by 4, right? By the way, this is also called a row matrix. Row matrix. Sure, because it only has 1 row. So also called a row matrix. And then what would D be? So you would describe matrix D as a 2 by 1. And of course, this would also be called a column matrix. Okay, so how do you describe a matrix? By its rows and columns. And we do use the X. Is a 3 by 2, a 2 by 3, a 1 by 4, and a 2 by 1. No 2 by 4s. All right. Elements. All right, so each element or entry can be located by their, I'm going to use my red here, row and column. By their row and column. Okay, so I want you to take a look at this. You can see here for matrix A, we call it matrix A. It's got a capital letter. And if you're going to follow, usually protocol is a matrix is assigned a capital letter. A capital letter. Now, when you see a lowercase letter, like this lowercase a, it means one of the elements of matrix A. It's lowercase a, so it's an element, one of the elements of matrix A. So you're looking at, and you're trying to figure out, well, which one is it? Well, of course, the key is all in the subscript, right? That's the key, is in the subscript. Here, I'll enlarge it. So this one has a subscript of 31. So which element would be element sub 31? Well, remember, math is orderly and things are in order. And how are elements located? By their row and column. So what element is in row 3, column 1 for matrix A? Row 3, column 1, and hopefully you say the -8. All right, so again, let me show you that here on matrix A. Here's row 3, and where does it intersect column 1? At element -8, right? Row 3 intersects column 1 at element -8. All right, so what would B sub 12 be? B sub 12. Which element is B sub 12? So we're looking at the B matrix, and hopefully you think, all right, row 1, column 2, and that's the 4, right? Take a look at the third one, C sub 11. It's only 1 row. Row 1, column 1, that's a 1. And D sub 21, row 2, column 1. Row 2, column 1 is the 1. Okay? So how do you locate elements or entries? You locate them by their subscript. And again, you'll use a lowercase notation. You'll use a lowercase to indicate an element and then a subscript to give the row and the column. All right, number 3, matrices are matrices can be used to represent data from spreadsheets, and I've showed you that already. Matrices can be used to represent data from spreadsheets. Let me get this a little bit higher. So if you take a look, I've got a spreadsheet off here to the right. We've got Bill and Gail as the columns. Bill is column 1 and Gail is column 2. And the rows are day 1, day 2, day 3. Now, if you produce this in Microsoft Word, then you can also go ahead and make up a chart on it, or I'm sorry, Microsoft Excel. Then you can make a chart out of it. And that's exactly what I did over here to the right. So you can see right here, I just clicked on a feature, and there's all kinds of charts you can make from data. So the program, Microsoft Excel, took the data, Bill and Gail in the 2 columns, and day 1 data, day 2 data, and day 3 data, and produced this chart. And so you can see Bill is blue and Gail is red, right? And so Bill on day one spent less on lunch than Gail did. But Bill on day two must have been really hungry, so he spent a lot on lunch and Gail not as much. On day three, probably Bill spent all his money, didn't have much left, and Gail had some left and she got more lunch than him. All right, but here's the reality with this. You can represent this data. So let's go back and look at the actual spreadsheet data right here. You can represent that data a couple different ways. You can represent it a couple different ways. You can represent it as a 2 by 3, or you can represent it as a 3 by 2. You can represent it as a 2 by 3 or 3 by 2. So, for example, let me go ahead and take Bill. Use a little color here, and he's blue, so I'll take blue. So, Bill, I can make a row of 3, 7, 2, right? Bill's day 1, day 2, day 3. So this first row is Bill, right? I'm going to take my red, and now I can do a row 2 and make that row 2 Gail. And what was Gail? 5, 4, 6. So I made up a 2 by 3, 2 rows and 3 columns. And in this situation, column 1 is day 1, column 2 is day 2, and column 3 is day 3. And so we made up a 2 by 3. Row 1 represents Bill, row 2 represents Gail. Day 1 is column 1, day 2 is column 2, and day 3 is column 3. Now you say, Mr. Scarfi, why did you do it that way? That's not really the way it looks in the spreadsheet. Yeah, I know. But again, I'm trying to get you to understand you can do it two different ways. The second example really follows the spreadsheet. So in the second example, we're going to make a 3 by 2. We are going to have 3 rows. 3 rows. But again, to use my color here, let me go ahead and do Bill as column 1. 3, 7, 2. So now, oops, that should have been blue. Let me grab my blue. Bill is blue. So, right, Bill is a 3, 7, 2. And what is Gail? Gail is a 5, 4, 6. You can do it either way. Now, in this case, day 1 is the first row, day 2 is the second row, and day 3 is the third row. Okay? A couple different ways you can do it. Either way is fine. There are advantages to representing the data one way than the other way. And in algebra, we deal a lot with points and coordinates. And so there's advantages, and you'll see that as we go on. But two different ways you can represent the data. Okay? All right, second page. So here we've got a we've got a figure, and what is it? 1, 2, 3, 4, 5. It's a pentagon. Is it convex or concave? All right, hopefully you think it's concave. It's caved in, right? Okay, and so it says create 2 matrices to represent the vertices of the figure. All right, let's help ourselves out. Let's go through first off. I'm going to grab my blue, and let's just get the coordinates of each point. All right, so this point is a negative 2, 1. I'm going to go clockwise, so up is a negative 3, 5. Working to the right here is a 1, 3. Continuing to the right clockwise is a 5, 4. And finally, our last point working this way around is a 2, negative 1. You must say, Mr. Scarfi, I wouldn't have known to go that order. It really doesn't matter. You just simply got to name all the points. Now, there's a couple different ways that you can make the matrix. I'm going to give you a pseudo domain approach. Domain approach. Why do I say pseudo? Because remember, if we're listing the domain, if any domain is listed, is there twice, you only list it one time. However, in a matrix, it's got to be listed every time. So that's why I say the pseudo domain approach. So we're okay in this one because it is a function, right? Every guy dates only one girl. Any abscissa has only one ordinate. Any x has only one y, right? Any input has a definite output. So we're okay with the domain approach. And in the domain approach, you would normally go in an order as to the you go lowest to highest, right? If you were going to take the domain approach. So if that were the way I were going to approach it, I would do -3, and I'm just going to do a row. -3, -2. Next would be a 1. Notice no commas or anything, right? Because a matrix doesn't have commas. Then would be a 2, and the last domain was 5. So -3, -2, 1, 2, 5. All right, so let me show you, make sure you're clear where I got that from. So remember, domain are x value. So I took this x value, -3. Then I took this x value, -2. Then I took this x value, 1. Then I took this x value, 2. And lastly, I took that x value, 5. I just went numerically from lowest to highest, okay? You don't have to do it that way, and I'll show you on the second one. But once I put in order, now I've got to go in order on that second row. So this second row, what y coordinate goes with the -3? That's a 5, right? I'm looking back at my chart. So again, see that 5 went with that -3, and this is what I'm doing every time I look for the y value. So next is a -2, and what goes with that? A 1. Next is the 1, what goes with that? A 3. Next is the 2, what goes with that? A -1. Next is the 5, and what goes with that? A 4. Lastly, go ahead and bracket it, and there's your matrix. We ended up with a what? A 2 by 1, 2, 3, 4, 5, a 2 by 5, right? So we ended up with a 2 by 5. All right, second one. So let's change it up. Let's change it up. What if I take the domains and I list them down? But instead of going domain, I'm just going to go clockwise. I'm just going to start at this point right here. All right, this one right here at -2, 1. So again, I'm only listing the x's, so I'm going to start with -2. And I'm going to work clockwise. So next would be this point up here, right? So that's a -3. And then next clockwise is a 1. And then next clockwise, the domain is a 5. And then finally, the last one, the domain is a 2. Okay. So now again, I'm just going to pair everything up. What y goes with -2? Okay, well that would be a 1, right? So across the first row is the 1. Now look at the second point. What goes with the -3? The 5. And again, I'm just going clockwise now, right? What goes with the 1? The 3. What goes with the 5? The 4. What goes with the 2? The -1. And now, again, I'll bracket it off. Now, I will tell you, sometimes whatever program is making the matrix wouldn't have the bracket capability, and they just do vertical lines. But technically, it's a little bit of a bracket. All right. But sometimes you'll just see vertical lines. It's not absolute value. It is a matrix, and it really is why it's supposed to be a bracket. Okay? So in this clockwise approach, I went clockwise around to list the points, and I also went vertically. In this, what do we end up with? A 5 by 2. Okay? So 2 by 5, 5 by 2. All right. Last thing I want to do is mention to you what we're going to do with matrices. And look, a lot of their value is in programming. Matrices or arrays come up in programming often. And what it allows you to do is it allows you to make similar type figures. So let me remind you of a few things that you learned in geometry. You learned of the term transformations. A transformation means that you're going to either translate, reflect, rotate, enlarge, or reduce an object. You're going to translate, reflect, rotate, enlarge, or reduce. So let me show you what I mean. All right, don't draw anything, just watch. So just watch. All right, so I already made this up to be exactly the same size. Okay, so it's exactly the same size as our original pentagon, brother. And I'm going to translate it. Translate means to simply move it to another location. Do nothing else but simply move it to another location. It doesn't spin. It doesn't enlarge or reduce. It doesn't reflect. It's just simply in another location. Now, it would be interesting to take a look at the coordinates of these points. And so, again, don't write this. I just want you to think. I'm going to real quickly show you the x coordinates. And believe it or not, they didn't change. -2, -3, 1, 5, 2. There's no change in the x coordinates of those points of the purple one. No change at all. But notice what happened to every y coordinate. Every y coordinate is 2 more. So the 1 becomes a 3. The 5 becomes a 7. The 3 becomes a 5. The 4 becomes a 6. And the -1 becomes a 1. Whoa. See, this whole column is +2 from the original column. And we translated the object up 2. Hey, what would you do to the second column if you wanted to translate it down 5? Well, you do -5 for every coordinate. How about this? What if, in addition to going up 2, what if I also wanted to go to the left 1? And now I got to reduce every x coordinate by 1. -1, -2, oh, -4, 0, 4, and 1, right? Whoa, there's the matrix. And see, this is easy mathematically, because you can give a command of the matrix and row 1 -1, and boom, you have the object translated that quickly. Right, that quickly. This is where we're going in our math. We're going to get there later. Don't worry about all this right now. I'm just trying to show it to you a little bit ahead of time. I'll show you how to do it later, but that's the idea. And just a few more thoughts here. Hey, remember to rotate. You can learn how to rotate. Usually it takes a trig function, sine, cosine, tangent, those kinds of things to rotate. We could reflect. It's hard to show you on here, the reflection of the object. I could definitely show you an enlargement, right? We can enlarge, right? And we can reduce. And so, believe it or not, the programming more than likely is using a matrix right now in its code to allow me to reduce and enlarge this object. It's matrices are found all over in programming. Again, usually they're called arrays, and so there's a lot of value there. Okay? All right, let me go back with a real short recap. Hey, don't forget, a matrix is a rectangular array of numbers. Rectangular array of numbers. How do you describe them? Rows and columns, folks. Rows first, columns second. Rows are horizontal, columns are vertical. You know the columns of a house are vertical. All right, columns of a house are vertical. Elements are located by their row and column. Little case a means an element of matrix A that's in the third row and the first column, right? Hey, there's a couple different ways to represent your data. And then we did that again here in creating them. All right, that's the idea. As always, when we flip the classroom, don't worry about your homework tonight. Advantage here is next time we meet in class, then you guys will be in class and working your homework there in class. All right, have a great night.